So by now you've already watched the vocab video, and in there we go through the full process of making a box and whisker plot. And there are steps here, and I expect you to learn and follow these steps. If you don't, you will have no idea what to do. So if you need to go back and watch that vocab again, or watch this again, it's available to you on Schoology 24/7, even if you're not in class, so you do need to do that. So, what we're looking at here is you're given a set of data, raw data right here. This is the table below, shows United States crop harvested from 1988 to 2000. Make a box and whisker plot. Well, rather than, I took it out of the table already and it's already here for you. Remember, your first step is to put it in order, smallest to biggest. If you don't do that, none of this can happen. So you cannot forget that. Then you go ahead and find the median. Again, the median's the middle number. So, now remember, if there is no actual middle number, so let's count this. Let's talk about how we found the median. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that means the middle number is your seventh one, right? If there was not actually a middle number, remember you would have to take the two middle numbers, you'd have to average them to find the middle numbers, add them together, and divide by 2. But in this case, there's an actual median there. So we're good to go. So 321, that is going to be your median. I'm going to circle it and mark it, M-E-D. Okay, then, if we continue, I need a thicker pen. Then, it says find the lower quartile. So that's at quartile 1 and upper quartile, which again really are just the upper and lower medians. So now to do that, you have to block out the actual median. So cover it up with your finger, whatever you need to do, cover it up so you don't see it. And you go 1, 2, 3, 4, 5, 6. So you take the lower half. There's 6 of those. Well, here, you're going to have to average the two because if there's 6, there's not actually a middle number, right? So again, remember, never use the actual median when you're finding the lower and upper quartile. That's the biggest mistakes kids make. So you cover that up and you go 1, 2, 3, 4, 5, 6. So 1, 2, 3, it's right between these two. So 314 and 317, you put them together, add them up, right? Divide by 2 and you get 315.5. So your median then is actually going to be right here, and that number is going to be 315.5. Okay? Then you look at the upper half and you do the same thing. There's 1, 2, 3, 4, 5, 6 numbers, right? Not a middle number. So it's right between these two, 326 and 326. Well, it doesn't take rocket scientists, right, to figure out that, well, the average of 326 and 326 is 326, okay? But it's not these 326s, it's this 326. I know that's weird. So this, we call that quartile 1, call this one quartile 3, okay? Because quartile 2 is technically the median itself. So the median we still have here, M-E-D. And then we also find, now this isn't labeled here directly, I don't know why they didn't do it. We find the minimum, that's the smallest number, that's real hard to find, and the maximum, that's the biggest number, also real hard to find, right? Then we go ahead and we make a number line that includes these numbers. Now I don't mean like right above these numbers, that'd be weird, it'd make it look even. So again, what I mean is you don't put it right above these numbers, you have to put it above an actual number line. And the smallest here is 298, so you could start at like 290 and go all the way to 350 like they did down here. And then what we do with these numbers, we take the minimum, we put a dot where that is. So our number line goes from 290, so we go down here to 298, which is right before 300, right? Put a dot there. Then the maximum, 333, figure out where that is, which is just past the 330, so put a dot there. Then the median, put a dot there, 321. Then quartile 1, that 315.5, put a dot there, right? Then quartile 3, which is 326, put a dot there. Now these 3 middle dots, you make a box around them, like I did here. Notice a line down the middle, and a box, and then just make the whiskers here and here. So that's the box and whisker plot, because it's a box with whiskers. I know, not a creative name, but whatever. So that's how we make a box and whisker plot. So your steps are, put it in order, smallest to biggest. Find the 5 points, and that's minimum, maximum, median, quartile 1, quartile 3. Then you draw the thing out. And if you need to go back and look at the picture again while you're making one, do it. It's not a big deal. Okay. Okay, so your turn to make one. You've seen me do a couple of examples now between the vocab and this. So go into class kick, your turn. Okay, now for this one. I'm going to go kind of slow. I know this video is going to get long, but I want you to get this down. So we have to put these in order before we do anything, or that was our first step. So we'll start with 1. I'm going to cross them off as I go here. 1, 2, 2.5 is next. 2.5. Let's see, 4, 5, 6, oops, 6, there we go. Looks like 6.2. 7 is next from what I can see. And then 8 and 9. And 18. Now, by the way, the great thing about box and whisker plot, and I'll talk about this in a second, though, is you can identify the outliers real quick. So that's a pretty cool thing about it. But we'll discuss that. So we've got a set of numbers, and we need to find the median. That's our first thing we're going to do, right? So let's do that. There's, I think there's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so the sixth one, 1, 2, 3, 4, 5, 6, is going to be the median. So that's this one right here. So 1, 2, 3, 4, 5. Yep, that's it. So this is our median. Okay? Now remember, we go to the lower half, so ignore that median now. We took it out. There's 1, 2, 3, 4, 5 numbers. So because there's 1, 2, 3, 4, 5 numbers left, I have another median. Pretty easy to find here. And so that's the middle one of these 5, so 2.5. Remember, we call that quartile 1. Then we go to the upper half, and there's 1, 2, 3, 4, 5 numbers. So the middle one there, let's see, this 8 right here is going to be our quartile 3. Then we have the minimum and the maximum. Okay? So those are the things that are going to make up the dots. Now, let's see, I go from 1 to 18, so and that's pretty easy to make a number line of, right? 1 to 18. So we'll go like this, make a number line, and we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Well, I could have made that a little bit longer, I guess, but yeah, it'll fit. We can just get rid of the rest of that. So, alrighty. So, and I do want to, you know what we should do though, actually? Maybe we should just make it longer so I can write in there easily. Let's do that. Spread it out a little bit. Alrighty. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There we go. Okay. Now, you don't know if just make a mistake, go back and erase it, redo it. Who cares? So we'll start with 1, 2, 3, 4, 5, 6, 7, 8. It's an 8, I promise. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then there's 20. Okay, making our dots. We have a dot at the 1. That's our minimum, right? Dot there. Dot the maximum. That's 18, right here. The median. Dot there. 6. I'm going to put a line through that one because I'm going to need that. 2.5 is quartile 1, so halfway between 2 and 3. Again, a line there because I'm going to make a box out of that deal. And a dot and a line at 8 because that's our upper median or third quartile. And we're going to make a box out of those guys. And then connect the rest as whiskers. Now here's the thing. You notice we have one really long whisker right there. See that? That means chances are there's an outlier, a number that sticks way out past the rest. And we can see that there is. So there's using your vocab words. We can see two kind of, if we have a clustering of numbers, that this is the middle 50% right here. Between 2.5 and 8 is 50% of the data. Half of it is right in there. 25% is here. 25% is here. Again, notice that outlier, because it should have ended about here, right? Should have been more even. Threw it way out there. Okay, so there you go. Making your own box and whisker plot. If yours is wrong, go back and fix it. I'm watching. Continue for another example. Now, the really great thing, or one of the really great things, I just like these box and whisker plots. I'm kind of a data geek anyway, but anyway, use box and whisker plots to compare orca whale masses and hippopotamus masses. Hippopotamuses? Whatever. All right, so orca whale, there's their list of data. Hippopotamuses, there's their list of data. Now again, you would have to put these in order. Find your upper and lower median, your first quartile, median, and find your minimum, maximum, quartile 1, quartile 3, and your median. Then put them on a number line, right? Same thing here. And when you have two together, you can make some comparison, have some discussion about them. For instance, we can look here and say overall, orca whales are bigger, right? I mean, look, their median is almost at the quartile 3 for hippopotamuses, so they're gigantic comparatively so. So overall, hippopotamuses are smaller. We can say that for sure. If we look at the orca whales that we sampled, it's kind of evenly distributed. I mean, it's a little off here, but it's kind of evenly distributed. There's two, especially the two whiskers. Whereas hippopotamuses probably have like one big guy here, right? Otherwise, they seem to be more clustered over here. So that's the kind of thing you're looking for. So in a sentence, you might say, well, overall, orca whales are bigger. That'd be okay. That'd be a good thing to be able to tell me from this set of data. And again, I know that because the overall box for orcas is far to the right of the hippopotamuses. Your turn. Go into class kick. Got another one for you. Okay, so I went ahead and put them in order before we started the video. Kind of save some time. If you didn't do that, do that. Right. First step. If you're skipping that, just stop. Just go back and do it. Okay. So let's get started here then. Starting with the first set of data. So we're looking for the median. There are 10 items, so there's not actually a median, right? It's actually between these two. Well, you can average those pretty easily, and that's 22, right? You add them together, divide by 2, you're going to get 22. And so we look at the bottom set of data, 1, 2, 3, 4, 5. We need the median there, so that is our 17, right? So this is quartile 1, this is the median, this is the minimum, this is the maximum, and then up here in the top, the upper half, this 24 right here. Now the other 24, this one is the quartile 3, and I'm picky about that when I watch you take my quiz and test. When I look at the answers, that you circle the correct 24. It's the one in the middle. Bottom set. Again, there's 10 items, so the median falls between these two. So you add 17 and 18 together, divide by 2, and you get 17.5. So it's not actually on the list, right? So there's our median. And let's see here. So the bottom half, this middle 16 is technically quartile 1. There's the minimum. And in the upper half, this 22 right here is quartile 3. And this is the maximum. Okay? So now then, put these two together, right? Put them on a number line together. It looks like this number line goes 15 to about 30. And I'm going to go ahead and just bring up the one that's pre-made here so it's clearer than my handwriting. So you made 2 of them. And you don't do this on my quiz and test, so you had to make 2 of them. So the upper one, again, I'm going to grab my my laser pointer. There we go. So minimum, right? Maximum. Median. Quartile 1. Quartile 3. Draw the box. Draw the whiskers. CDs, same thing, right? Median. Quartile 1, quartile 3, max, min, draw the box, draw the whiskers. What can you say about them? Well, you can say overall that video sales are higher, right? Because that box is far to the right. Looks like video sales also have an outlier, a big number. But, there is some numbers in there, but it certainly looks like maybe there's some more stuff towards this end and the upper end of sales in millions, that sort of thing. So, there you go. But again, you make them and be able to tell me a little something about them. I know it's getting long, but continue for more examples. On this one, don't have to make one, luckily, right? So a little describing of the data. Describe the data in the box and whisker plot. So here, whatever this is exam scores, right? Minimum, maximum. Median score is like, what, about 75? And we got quartile 1, quartile 3. So things we can say about this. The lowest score is 50. The highest score was 90. Half of the scores fall between 65 and 80. That's what this box means. Half the scores between 65 and 80. Again, we could say that the median score was 75. So there you go. That's the stuff I expect people to tell me about it. Tell me the min, tell me the max, tell me the median score, tell me half the scores fall, and then give me the numbers for the box. Again, in this case, 65 to 80. That's what I'm looking for. You might also mention how the median is a little bit to the right of the box. If it was dead center in the middle of the box, you'd say, oh, it's evenly distributed. But it's not because it's a little bit to the right. Pause, go ahead and head into class kick, and your turn. And I'd like to see you write out what you're going to have in there. Here you can already see what I have down below. So again, important things to tell me. The lowest score here, right, whatever this data was, is 15. The highest score is 45. The median is about 35. 50% of the data, half it, falls between 25 and 40. And you can say it's a little bit skewed here, so it's a little heavier to the right because this is not, the median line is not dead center in the box. Continue for one more example. More things you can say. This puts 2 on the same again. So this one shows number of people registered to vote, number of people who actually voted. This is kind of a common problem, by the way, in our country. People who, well, yeah, I'm going to vote, and then they don't. Go out and vote. Make your voice heard, right? That's how we get things done around here. So things you can say. Well, we can say overall more people registered to vote than actually voted. We can say that the clustering of people who actually voted is tighter. Notice how small the box and whisker is here. Versus here, the people who actually voted is kind of spread out. So percentage of population who registered. Again, this is over a 10-year span each year and kind of looking at the data. So again, you can see down here, it says, therefore you conclude that many who registered to vote did not. Slackers. Pause here. Another one for you to go into class kick and finish up. Okay, so this time we're comparing the height of women and men Olympic basketball players. Looking at this stuff, you can see right here, here's men, here's women. Overall, men were taller. Women, look how consistent this looks. These whiskers are almost equal. This box is spread out almost equally. So you could say women are more consistently spread out height. Men, there's a few outliers, right? This guy's probably like a short guy. I don't know, Charles Barkley or something, right? But again, here overall men are taller. And you can say for average male height is about, about 79? Average woman height's about 71. So that's things you can tell me.